Alright, well, this is the second time I've made this video. I made an error in the first one, not a mathematical error, but a recording error. Okay, so we're going to have this differential equation. It's going to be the t derivative of u plus the x derivative of u equals minus u. Okay, so the new thing here is that the right-hand side is not just equal to 0, and we have u is equal to t on the t-axis. I can't remember if this is the new thing. I can't remember if having u being equal to 0 on the t-axis is new for this video or not, since, like I said, I'm making it for the second time now. Okay, so for the t-axis, we're going to have 0, comma t naught as our parameterization. Again, I could have that be a theta, have it 0 theta, but I think since we're on the t-axis, I'm going to use t naught, since I think that variable is a little more descriptive. Okay, so as always, x prime is going to be equal to whatever is multiplying the x derivative of u, which is 1. T prime is whatever is multiplying the t derivative of u, which is 1. And z prime is going to be the right-hand side. But notice, I just want to recall, z of s is defined as u of x of s, t of s, and we saw by the chain rule that z prime of s is going to be x prime, which in this case is 1, times the x derivative of u, plus t prime, which is 1, times the t derivative of u. And this is all u of x of s, t of s, u of x of s, t of s. But this is just the left-hand side of the differential equation. So this is equal to minus u of x of s, t of s. Well, that's just what z is. Okay, so whenever you see u, that just means z, because we're only looking at z along these characteristic curves. That is the curves defined by x and t here. Okay, so this is going to be equal to minus z. The initial values, x of 0 is equal to 0. T of 0 is equal to whatever that is there. And then z of 0 is always going to be u of x of 0, t of 0. That is u along the boundary. So in this case, it's just going to be equal to t naught. Okay. So again, this system is easy to solve. X prime is equal to s, x of s is equal to s. T of s is equal to s plus t naught. Z of s is going to be the new thing here. It's z prime is equal to minus z. The general solution is z of 0, which is t naught, e to the minus s. Okay. And so let's sketch some of these characteristics. This is the x-axis. This is the t-axis. Okay, so for a generic t naught here, let's call this t naught. We're going to have a slope. The characteristic is going to be a slope of line, a line of slope 1. The slope is just the coefficients, the ratio of the coefficients. A line of slope 1, not a slope of line 1. I'm losing my mind here. Okay, so we have something like this. And then we might have another characteristic right here, going like that. Okay, now notice the new thing. If I consider, let's say, this characteristic right here. If I start here and kind of move my way in this direction, as I go s feet, where s is the parameterization here, I know that at this point, the solution is going to be equal to t naught e to the minus s. That is, if I assume I've traveled s units in that direction. Okay, well, maybe this is helpful to have a good geometric picture of what's going on, but when we report the solution to the PDE, we don't want to say, okay, well, you start on the t-axis and move your way that way, and this is what it's going to be. Now, maybe that's helpful in some cases, but we want a formula. We want to say u of xt is equal to something. In other words, as we've done with the previous examples, we want to start with the point xt in the plane, and then figure out what the appropriate, t naught and s are. I'm going to start from right here, actually. Okay, right here. Okay, so this is my xt, so I'm going to trace it backwards to see where it crosses the t-axis. this case, it's going to be right here. This is the T naught, and then, see, what my S value is, and that's going to give me U at that point is going to be equal to T naught e to the minus S. Well, again, geometrically, that's what's happening. I'm tracing back to T naught and then going forward to see whatever this S value is there. But algebraically, the way that I figure out what T naught and S are is I just solve the equations. X is equal to S, and T is equal to S plus T naught. Okay, so again, Z here depends on both T naught and S. It's our first one that depends on both T naught and S. Well, so I need to solve this for S and T naught in terms of X and T. S is equal to X, that's pretty clear. So if you come down here, this is equal to X plus T naught, and so T naught is equal to T minus X. And so U, for that generic point there, but it works for all points, U of xt is going to be equal to T naught, which is T minus X, times e to the minus S, which is e to the minus X. And so U of xt is equal to this function there. And again, just like for all of the other ones, I encourage you to show that this solves the PDE and this condition here, not just for a limited selection of X and T values, but for all X and T values in the entire plane.